In this lecture, we will start by introducing what is force, and then we will move on to understanding the characteristics of force. As you all are aware, force is an agent which produces or tends to produce, destroys or tends to destroy the motion of a body or particles. So in simple language, you can define force as a push or a pull that produces or tends to produce, destroys or tends to destroy motion of a body or particles. Force, as you know, is a vector quantity and SI unit of force is Newton. Moving on to the characteristics of force. A force is completely defined only when the following four characteristics are specified. To understand the characteristics of force, I have considered an example here. So, I have considered a ladder AB which is kept against a wall, and at point C, a person weighing 600 Newton is standing. The force applied by the person on the ladder has the following characteristics. First characteristic is magnitude. So the magnitude of the weight of the person who is standing at point C is 600 Newton. The point of application of that force is at point C, which is 2 meters from point A on the ground. The line of action is vertical and the direction of the force is in the downward direction. So you can see the arrow is pointing downwards. So the direction is downwards. So you can explain the force which is acted by the person at point C on the ladder by specifying its magnitude, direction, point of application and line of action. Moving next to system of forces. What do you mean by system of forces is when several forces of different magnitude and direction act upon a body, they constitute a system of forces. So, if I have a body and on that body there is more than one force acting, then that forces will constitute a system of forces. So now the force system can be classified into coplanar force system and non-coplanar force system. Coplanar force system can further be divided into collinear force system, concurrent force system, parallel force system and non-concurrent, non-parallel force system, and non-coplanar force system can be further classified into concurrent force system, parallel force system, non-concurrent, non-parallel force system. So let us now understand each of these force system by considering a figure. So first let us understand all the coplanar force systems, starting with coplanar collinear force system. What do you mean by coplanar is if the forces lie on the single plane, then it is called as coplanar force system. So you can see here all these three forces F1, F2, F3 are lying on the single plane, that is XY plane. And what do you mean by collinear is you can see all the three forces are acting along the same line. So that is the meaning of coplanar collinear force system. Moving next to coplanar concurrent force system. Again, coplanar means they are lying on the same plane. What do you mean by concurrent is, if you can see here, all these four forces are acting at a single point. You can see F1, F2 and F4 are emerging from the same point, while F3 is meeting at the same point. So that is the meaning of concurrent. All the forces are either meeting at a single point or they are emerging from a single point. So that is coplanar concurrent force system. Moving next to coplanar concurrent collinear force system. Coplanar, you know, that is single plane, the forces are acting. Concurrent, that means they are emerging or meeting from a single point. And what is collinear? They are lying on the same line. Next is coplanar parallel forces. What do you mean by that? Again, coplanar is lying on the single plane. Parallel, you can see all these three forces are parallel to each other. Again, one more example of coplanar parallel force system is this one. You can see here all the forces are in the same plane and all forces W1, W2, W3, RA and RB are parallel to each other. Last type of coplanar force system is coplanar non-concurrent and non-parallel force system. So what do you mean by coplanar? As you are aware now, all the four forces here are lying in the same plane. What do you mean by non-concurrent is, you can see all the forces now are not emerging or not meeting at the same point. You can see P2 and R are meeting at a single point, but P1 and W are acting at different point on the system. So that is the meaning of non-concurrent. And what do you mean by non-parallel? You can see all these four forces are not parallel to each other. So this is coplanar non-concurrent and non-parallel force system. Let us now move on to non-coplanar force systems. So first one you can see here is non-coplanar concurrent force system. So now what is the meaning of non-coplanar is, you can see in the figure now all the forces are not lying in the single plane. So that is the meaning of non-coplanar. What is concurrent? You can see here all the forces are meeting at a single point. So this system is non-coplanar concurrent force system. Moving next to non-concurrent non-parallel force system. What is non-concurrent? You can see all the four forces are not meeting or emerging from the same point. And what is non-parallel? All the four forces are not parallel to each other. Lastly, coming to non-coplanar parallel force system. So non-coplanar means they are not lying in a single plane. You can see some are lying in XY plane, some are lying in XZ plane and some are lying in YZ plane. If I consider this as X axis, this as Y axis and this as Z axis. So that is the meaning of non-coplanar. What is the meaning of parallel? You can see that all the forces are parallel to each other. If they are lying in one particular plane, they are parallel to each other in that plane. The next concept that we will study in engineering mechanics is finding resultant. What do you mean by resultant is, resultant is a single force obtained by combining a system of forces such that it has the same effect on the rigid body as the original system of forces. So if I have a body and on that body there are n number of forces acting. So if I am considering n number of forces acting on the body, it will constitute a system of forces. Okay. So now if I am asked to find the resultant, what I have to do is I have to convert that n number of forces into a single force, and that single force will have the same effect on the body as the n number of forces were having. That is the meaning of resultant. So you can see an example here. I've considered a body. On this body there are two forces acting. One is 10 Newton, second one is 20 Newton. If I'm asked to find the resultant now, what I have to do, I have to convert these two forces into just one force. So that I have done here. I have replaced these two forces by a single force, and this single force should have the same effect on the body as these two forces were having. That is the meaning of resultant. So let us now see how to find resultant when there are two forces acting, three forces acting on a body, or more number of forces or n number of forces acting on the body. So let us first start by finding resultant when there are only two forces acting on the body. So parallelogram law of forces is the law that helps us to find resultant of only two forces acting on a body. So what does the law say is, if two forces acting at a point are represented in magnitude and direction by the two adjacent sides of a parallelogram, then their resultant is represented in magnitude and direction by the diagonal passing through the point. So what does this law say is, if I have a point and there are two forces acting at a point, and let theta be the angle between the two forces, what we have to do is represent these two forces by two adjacent sides of the parallelogram, and what we have to do next is complete the parallelogram and then draw the diagonal. Then the diagonal which is passing through these two forces will give the resultant due to these two forces in magnitude and direction. So resultant by parallelogram law of forces is given by this formula, which is root of p square plus q square plus 2pq cos theta, where p is one force, q is the second force, and theta is the angle between the two forces. So since resultant is a vector, we have to find the resultant in magnitude and direction. So using this formula, we will be able to find the resultant in magnitude. How can we find the resultant in direction? Is by using this formula, which is tan of alpha is equal to q sin theta divided by p plus q cos theta. So alpha will be nothing but tan inverse of q sin theta divided by p plus q cos theta. So if I have two forces which are acting at a point, okay, so if I have the magnitude of these two forces and I have the angle that the two forces make with respect to each other, using these two formulas, I will be able to find the resultant in magnitude and direction using parallelogram law of forces. In this lecture, we will be finding the resultant due to two forces acting at a point. So we are given a force system here. At point O, there are two forces acting. One force is of magnitude 10 Newton and the other force is of magnitude 20 Newton, and both are acting at point O. So this particular system is an example of coplanar concurrent force system, because there are forces which are on the same plane, and all the forces, that is these two forces, are acting or emerging from the same point O. Let us now see how to find resultant when there are only two forces acting at a point and both the forces are lying in the same plane. The first solution that we can find is using parallelogram law of forces. Parallelogram law of forces have given us this formulas to calculate the resultant due to two forces acting at a point. So the formula given is resultant is given by square root of p square plus q square plus 2pq cos theta. Now P is one of the force that I have considered here is 10 Newton. Q is the second force that is 20 Newton, and theta is the angle between the two forces. The angle between the two forces given to us is 30 degrees. So let us substitute the value of P, Q and theta in the formula. So if we do that, we get the resultant as 29.09 Newton. So we have found the resultant in magnitude. We know that resultant is a vector quantity, so it will have magnitude as well as direction. We have found the magnitude. Now let us move further and find the direction. So parallelogram law of forces has given us the formula to find the direction, that is angle made by the resultant, and the formula is tan of alpha is equal to q sin theta divided by p plus q cos theta. Let us substitute now the value of q, the value of p and theta in this formula and find what is the answer of alpha, that is angle made by the resultant. So if we solve that, we get angle made by the resultant as 20.10 degrees. So we have found the resultant using parallelogram law of forces in magnitude and in direction. So this particular type of solution is called as analytical solution. What do you mean by analytical solution is we have formulas with us. We are just substituting the given values into the formulas to find the unknowns. Let us solve now the same problem graphically. What do you mean by graphical solution is now we will be doing some sketching or some drawing will be done in order to find the resultant. In the previous solution where we had found the resultant analytically, we were using formulas, parallelogram law of forces, the analytical solution, that is formulas, we were putting the known values and we were finding the unknowns. So that was a very quick method of finding the resultant because you had to just memorize the formulas, put the known values and get the unknowns. Now let us see how we can graphically find the resultant using graphical solution given by parallelogram law of forces. For that again I have considered the same problem. At point O there is one force of 10 Newton. At point O again there is one more force of 20 Newton acting, and both are making an angle of 30 degrees with respect to each other. So if we have to find the solution for resultant graphically, we have to start by using a scale. So the scale that I have used here is let 1 Newton be equal to 0.5 centimeters. So take the first force which is 10 Newton. If 1 Newton is 0.5 centimeter, what will be 10 Newton equal to? 10 Newton will be equal to 5 centimeters. So what I am doing? I am drawing a horizontal line, okay, of 5 centimeter that will represent 10 Newton. So basically what I am doing, parallel to this force of 10 Newton, I am drawing a line of 5 centimeter which is representing 10 Newton as per my scale. The next step what we have to do is I'll keep my protractor at this point and I'll measure an angle of 30 degrees. Okay, because the angle between the two forces is 30 degrees. So I'll keep my protractor here, measure an angle of 30 degrees, and at 30 degrees I will draw a line. So now what should be the length of this line is that should be equal to your second force, that is 20 Newton. So as per my scale, if 1 Newton is 0.5 centimeter, 20 Newton should be equal to 10 centimeter. So I'll draw this line which is passing through this point where we had marked 30 degrees. That line will be equal to 10 centimeter. Now what we have to do is complete the parallelogram. What are the properties of parallelogram is the opposite sides are parallel and equal. So if this side is 5 centimeter, that is 10 Newton, parallel to that I will have to draw a line of again 5 centimeter, and if this line is of 10 centimeter, parallel to this at this point I will have to draw a line of 10 centimeter. So if I do that, my parallelogram will be complete. And what is giving us the resultant as per the parallelogram law of forces? That is the diagonal which is passing through these two forces. So if I join this point, if I now join this point to this point, that is the diagonal passing through the two forces, this is one force, this is the second force, then the diagonal will give me the resultant in magnitude and direction. So what I'll have to do now is I'll have to measure the length of this diagonal. So the length of my diagonal comes to 14.55 centimeter. So I have got the resultant now in terms of length. What I have to do using my scale, I'll have to convert that in Newton. So if 1 Newton is 0.5 centimeter, how much will be 14.55 centimeter? If I do the calculation, I get the resultant to be 29.09 Newton. So I have got my resultant now in terms of magnitude. How will I get my resultant in terms of direction is I have to measure this angle from this line that is representing one force to the diagonal which is representing the resultant. I'll have to again keep my protractor at this point and measure this angle. So if I measure that angle, I get the angle made by the resultant to be 20.10 degrees. So this is the way you can graphically find the resultant of two forces acting at a point using graphical solution given by parallelogram law of forces. Okay, so if you see this particular solution, it will take a little larger time as compared to the analytical solution because you have to do this sketching and that will take time.